Okay, so I don't know, do you remember what was the problem last time? I should have it somewhere. I asked you to work a little bit on it. So the problem that we solved last time was this problem. So we had an inclined surface. Yes, something like that. And then we knew about this angle. This angle was given to us from the beginning. It was called phi. And then we have a projectile. We have the initial speed we know, vector we know, and then we know that this angle here is theta, it's bigger angle, and then we calculated more or less completely mathematically that this range on this inclined surface follows this formula. So it is 2v node squared. Here, of course, v node is the length of this vector. And then multiplied by cosine theta, sine. The first one was cosine, the second one was sine of theta minus phi. Yes, divided by g cosine squared phi. Yes. So if you remember, we solved this problem purely mathematically. We just I don't know, we consider this to be a line in the coordinate system. So we consider this coordinate system as usual, horizontal line and the vertical line. And then we wrote, actually we were able to use the result that we got before for this trajectory. We found the equation of this trajectory is a parabola. We had the formula on board, and then we found the formula for the equation of this line, and then we intersect them together and find the distance from the origin, and that would be. But then I ask you, this will teach you quite nice physics. If you try to change your perspective, if you change your coordinate system instead of the usual one, let me consider this coordinate system. Let me, for distinction, call it capital X, and then let me call this one capital Y. And if you don't want to, mind to compare this, let me draw the old coordinate system as well. So the old one that we chose and we were able to successfully solve the problem was this coordinate system. It was X here and it was Y here, yes? Okay, we already did it in this red coordinate system, and that's completely okay. But I told you that that was a completely mathematical solution. Let us now try to solve the problem in the blue coordinate system, capital X and capital Y. Let me call this point O, for example, the origin. And let us see actually what happens here. So how do you think that I need to start to solve this problem now in this new coordinate system? From scratch, exactly. From scratch, principles of physics.
Newton's second law.
Yeah, we start from the second law. Yes, so as the second law is actually a vector equation, but we are working in 2 dimensions. So this vector equation m times a can be decomposed into 2 parts. Yes, this is equivalent. So let me write this the other way around. So this one single vector equation is equivalent to 2 equations. So one equation is that, let me write f of capital X. This is not just little x. And then m is m. It doesn't depend. By the way, this is also important to understand. M is m regardless of the coordinate system that I am choosing. These kinds of quantities in physics are called
constant.
No. No. There is a specific name. We have 2 kinds of quantities in physics, yes? Scalar quantities. Yes, exactly. So a scalar quantity is a quantity which does not depend, its value does not depend on the coordinate system that you are using. For example, temperature. Temperature is a scalar quantity, yes? But velocity is not a scalar quantity, yes? Because it depends in which coordinate system you are measuring. For example, if you are on a train and you shoot a ball, the speed of the ball with respect to you is different from the speed of the ball with respect to someone which is actually standing on the, I don't know, on the station, yes? So this means that this depends. So the quantity depends in which coordinate system you are looking at. So that's a vector quantity. Of course, it's a little bit more technical than that. But anyway, scalars are nice. Scalars means that it doesn't matter which actually coordinate system we are using. The value is always the same. And the same is, there is a word in physics, we call it invariant. So we say that M is invariant under coordinate transformation. I am going from one coordinate system to another coordinate system, but the value of M does not change. It is invariant. So that's called a scalar. Okay, but then I would write it as A, X, and then we write f of capital Y is M, A, capital Y. Just for refreshing your memory, in the old coordinate system, this is the same vector equation, but in the old coordinate system, it reads like this. Okay, so let us just do it again here to refresh your memory. Okay. So what is f of x? Remember, this little x and little y refers to this old coordinate system. So what is f of x here? So this is your particle moving. So this is your particle moving. So what is the force acting on this particle? The only force, if you just ignore the air drag,
Gravity.
Just gravity, and you know that this is mg. Yes. Okay. So when I say mg, I am pointing it downwards. So that is the direction. So mg is just the length, is the magnitude of this vector. So what is f of x here?
0.
It's 0. Yeah. So you write 0 is equal, m is m. So what is ax? Ax is the acceleration on the x-axis. So what I have to do, I need to project it on the x-axis, and from here to here. So let me. From here to here is x. This is the x coordinate of my moving particle. Yes. So what should I write here? I should write x double prime. Do you agree? So let me take these things away. Yes. So this becomes x double prime of t. Yes. That is the equation. But you know how to solve it, so I don't continue. But let me write this one. What is this one here? What is f of y? What is f of y?
Minus
mg, yes, because it's in the wrong direction. It's in the opposite direction. M, and then instead of ay, what should I write? I should write y double prime of t. Yes, so that's the y coordinate here. Yes, of course. Yeah, so that's the y coordinate. Do you have questions?
No.
Okay. So this is y. Is that okay? That was the equation, and if you remember, we were able to solve these differential equations and find it. But I want you to do this in this coordinate system for me. So what do you think would be the force x? Is it still 0? It's clearly not, yes? Because now, if I want to see what this is a little bit bad picture, but I hope that you agree with me. This is a vector. Let me just draw it here for you. This is a vector. mg. Let me a little bit exaggerate here to understand what's going on. So I have this. So let me just draw it. By the way, you know that vectors doesn't depend on location. So it doesn't matter if you draw this vector from here or you draw it from here. Because as soon as you keep the direction and the length the same, that's the same vector. Okay? So if I draw it from let me just do it here. So if I want you to understand that I need to decompose it onto this in this way. So this is, I set up a local coordinate system, but imagine this coordinate system is the same coordinate system. I have moved it a little bit. This coordinate system, I don't mean it is moving by your particle. I'm just drawing some parallel lines from here so that you understand. So you see that this is the x coordinate and this is the y coordinate. If I ask you what is the x component of this force, what do you say?
Oh.
It needs a little bit geometry. So let me draw this picture here for you. you have m, your particle is here. This is your vector. Okay, this is your mg. Oh, yes?
It's a negative cosine theta.
Yeah, something like that. mg negative cosine theta. Okay, so what you need to do, so here I am drawing a parallel line here, and then I am drawing a vertical line here. So this angle is 90. Okay, so if I ask you, theta is no, phi, not theta. Yes?
Phi.
Yeah, it should be phi, because this angle is phi. Do you agree with me that this angle is also phi? Yes, why is that? Can you tell me from geometrical picture why that angle is phi? So what you see, this line is parallel to this line, and this line is perpendicular to this line. Then I am claiming that if this angle is phi, this angle will also be phi. Why is that? This is also a nice theorem from geometry. It's good to know. If you have an angle like this, if you have another angle, one leg is perpendicular to this and another leg is perpendicular to this. Remember, this, if this angle is u, this angle is also u. This is trivial, yes? Why? Because these two angles are vertical angles, so they have the same size. Yes? So this angle, let me call it x, this angle is also x. But if I ask you what is x plus u in this right angle triangle, it is 90. If I ask you what is x plus, let me call it v, if I ask you what is x plus v in this bigger triangle, you will also say 90, yes? So this means that x plus u is equal to x plus v, so this means that u and v are the same. So if you have two angles like this leg is perpendicular to this leg is perpendicular to that leg, then, and this vertex is outside, because if the vertex is inside, this would be different. If the vertices are outside of each other, then these two angles should be the same. Why? Because if I have this scenario, if I have another, if the vertex is inside, you see, if I draw this one 90 and this one 90, this is clear that this angle and that angle are not equal. These angles are supplementary. If you add them, it becomes 180 degrees. Yes. So these are very nice theorems in geometry, which will immediately help you to solve a lot of physics problems. So you need to have these pictures in mind. Yes. So if I have two angles, side by side, they are perpendicular to each other, and the vertices are outside of each other, then these two angles are the same. But if one vertex is inside the other one, these two angles are not equal, they are supplementary. If you add them, it becomes 180, yes? So I hope that you agree, this is the same scenario. Do you agree now that if this is phi, this is also phi, yes? Because what happens if you continue this in your mind, this is 90, if you continue this one, this is also 90. According to that picture, if this is phi, that's also phi. Yes? Is that understandable? Okay, now let me try to write this physics equation. So this tells me that, tell me the component of my force. The force of gravity is the only force affecting the particle here. On the x direction. What is x direction? This blue line is the x direction. Here it's x direction. Yes? So what is the answer? The answer, as you said, it is minus mg cosine phi. I want to make sure that you... No, sorry, it's not cosine. Did you say cosine? So it's not cosine. What is it?
Tangent.
No.
Oh, no, it's sine.
It's a sine, yes? Because you want... So this is... Let me clean this. If I decompose this vector in this and that, this one is the one on the y-axis, and this one is on the one on the x-axis. So I am on the x-axis right now, so this is the opposite side, and this is the hypotenuse, so it becomes sine. So minus mg times sine of phi is equal to m. Okay, can you tell me what can I write for a capital X?
X capital, the second derivative.
Yeah, exactly. The second derivative of capital X. Yes, that's the meaning of derivative. That's the meaning of the acceleration. Is that clear? Yes. Okay, so that's a differential equation. We can solve it now. So don't get confused. G is a constant. Sine of phi is a constant because phi is constant. M is a constant, not zero. So I can just simply drop it. So what happens? You get minus G sine phi. Now you understand a little bit of the physics here. So let us go back to the previous version of my solution. What happens here? When I drop it, x double prime is 0. So it means that if you choose the red coordinate system, the particle is not accelerated along the x direction. But now if I change my perspective, my particle is still accelerated in the new x direction. The new x direction is different from the old x direction. If I choose this one, the motion on this direction is very simple. It's a uniform velocity motion. But when I change my perspective and go to this blue coordinate system, it's a uniform accelerated motion. Yes, because this is a constant and that's the acceleration. So now we can solve this differential equation. So how can I solve this differential equation? I take a primitive function. So what is a primitive function? Just tell me. Yeah, what's the primitive function? What's that?
Cosine.
No. This is why I'm asking you. You shouldn't let these physics distract you. This is just pure mathematics. So what's the variable here? It's t. So g and phi are constants. It's like 5. It doesn't matter. It's just like a number 5. Whatever it is, g and phi are constant. So that combination is a constant. So if I have a constant, and if I want, by the way, let me just increase the voice. I cannot hear you. Alexander at home. Yeah, that's the highest one. You need to shout a little bit. Okay, so no, this is phi. Don't get confused. So g is a constant, phi is a constant, g sine phi is a constant. Yes? Yes, what's that?
Negative G sine phi t.
No, there is no cosine involved. This is sine, yes?
Yeah.
What is that?
Negative G sine phi and then t.
Yes, so it
Plus
is
a constant.
negative g sine phi, it's a constant, and then multiplied by your integration variable, which is t, but it's not finished,
Plus a constant.
plus a constant. Let me call that constant c. So that's the usual constant that appears in mathematics all the time. Yes, we usually don't care about that, but in physics it's crucial to care about this constant. Okay, now I want to find x, so I need to differentiate once more. So I need to integrate once more. So what would be that? This is again a constant. A primitive function for t is what? Minus 1 over 2 g sine phi t squared. Do you agree with me? Yes? Because again, this part is a constant. Who cares? And I'm asking you what is a primitive function for t. A primitive function for t is t squared divided by 2. I have written it in that way. What is a primitive function for constant c? It is ct, but it is not enough. I need to write another new constant. Whenever I integrate, I need to bring the integration constant in, yes? But of course, this is not mathematics, this is physics. So we need to care about these constants. What are these constants? These constants are fine-tuned by the initial conditions, okay? What do I mean by initial conditions? I mean initial position and initial velocity. So if I ask you, what is x, capital X at instant 0? When I just shoot the particle is originally here, initially here, yes? So what is x of 0? We know x of 0 should be 0, yes? Okay, this we know, because at initial it is there, so I put it here. When I put 0 instead of t, this is gone, d is left, equals to 0. So this means that d is 0, okay? So one of these constants is equal to 0. Okay, how can I fine-tune the other constant? I want to find c here. C is somehow related to initial velocity, yes? So can you tell me, what is, this is nice physics, by the way, what is x prime at 0? the initial velocity of my particle in the x direction. What is that? This is your initial velocity independent of any coordinate system. This is the vector of your of initial velocity of your particle. But now I am interested in the initial velocity of this particle along this blue axis. Yes, axis.
Is it cosine of theta minus phi times v0?
Yes. Is that understandable? Because you see, automatically these angles come into the game. Yes, because this I need to find the component of this vector on this line. But this big angle is theta, this part is phi, so this angle here is theta minus phi. And then I multiplied v naught by cosine of theta minus phi, that would be my angle. So that would be my initial velocity. So this becomes v naught cosine of what? Theta minus phi. Do you agree? Do you agree with what I have written here? So it's extremely important. Usually in mathematics, we don't care about these poor constants, but in physics, it's crucial because the differential equation is not sensitive to the initial condition. The solution itself is very sensitive to the initial conditions. Okay, and then what I have to do, I go back here because that is x prime of 0. Instead of t, I put 0. So what happens? This is gone. This becomes c, yes? If I put 0 here, this is gone. C is left, is equal to this guy. So this I got it, yes? And now I can write my equation. Now I know everything about this particle on the x direction. It is minus a half g sine phi t squared plus c, but I calculated c, multiplied by t plus d. D is 0. So it's very nice, you see. I think you learn a lot of physics by solving it in this direction. So it's different. So is that understandable? Yes? Okay. Now we want to do the same thing for the second differential equation. So let us just do it together. So if you don't mind, let me clean this. We don't have enough space here. So what should I do? I go back here. What is Fy? Can you tell me? In the previous case, Fy was mg, minus mg. But of course, it is clear that in this new case, it is not minus mg. What do I need? I need the y coordinate. This is what I need, yes? It is in the y direction, capital Y direction. So what is this one? Yes?
Negative m cosine of phi.
Negative mg cosine phi, yes? So instead of Fy, I put negative mg cosine phi. On the right-hand side, I have m. But what can I write for ay? I can write y double prime t. That's the acceleration on the y direction. And then what happens this time, m and m are cancelled. So what I get is y double prime of t is minus g cosine phi. And then that's it. So let me just immediately solve it. So that's more or less the same thing. So I integrate once. This is a constant. So it becomes minus g cosine phi t plus a constant. So let me call the constant e this time, not to confuse it with the previous ones. And then I do once more. So y of t is equal to minus 1 over 2 g cosine phi t squared plus et plus, let us say, f. Okay, the same story. So I have to do the initial conditions. So what is the initial condition now? What is y at 0? Do you agree this is the same 0 because y is there? So this gives rise that f is 0. That's the same story. So let me just make it short. Yes, f is 0. And then what is x prime? So what is y prime 0? Can you just review it again? So what is y prime of 0 this time? What is y prime 0?
V node times sine
Of
theta minus
phi. Yes. So we are interested in this vector. Yes. This vector is the hypotenuse, the length of the hypotenuse multiplied by the sine of this angle, which is theta minus phi. So this means that y prime at 0 is sine of theta minus phi. Yes? But what is y prime of 0? If I go to y prime and I put 0, I get e. So this means that my e is this. This is my, this is my e. And then let me write everything below here. So yt is equal to minus 1 over 2 g cosine phi t squared, and then e is this guy. And that's it. Yes? Understandable? Okay. Now let me clean this mess and make it more nice. So we now have the equations in the new coordinate system, of course. Yes. So let me draw the picture once more, because I want you to have a good understanding of what's going on. So here, my problem was this. Do you remember? So I have this inclined surface, and then here this is phi, and then I don't know, shoot a particle by this initial velocity v node, and then this will go like that, and then hit this. At some point, we want to measure this length. Yes, we want to show that that is this length. Okay, but now this is my new coordinate system, and I know everything of regarding the position of my particle, both in the x direction and in the y direction. Okay? Okay, so now can you tell me how should I solve this problem using these new equations? I want to find this d.
Find that x equals 0 somewhere.
No, x is not equal to 0, yes? Yes, Emil?
Y equals 0, sorry.
Yes, we put y equal to 0 because when the particle hits this inclined surface, at that point, so let me by the way, let me ask you, so what is the coordinates here? What are the coordinates? If I call it A, in this new coordinate system, the x coordinate is just d, do you agree? And the y coordinate is 0 because it lies on this x-axis. Okay, so what I need to do, I want to ask myself when the y coordinate of the particle becomes 0. So I go to the y equation and put y equal to 0 and calculate the corresponding t. Yes, of course, one of those t's is already clear. Yes, the y coordinate becomes 0 at 2 points. Once in the initial point, once here. Yes, so if I put yt equals to 0, this means that I get the time. I calculate the time that it takes for the particle to hit the inclined surface once more. So let us go to y and put it equal to 0. T squared, and then plus v node sine of theta minus phi t. I put it equal to 0, and I want to find t. Yes? Of course, it is clear there are two t's, yes? If I put t equal to 0, this equation will hold, and that is not surprising because my particle is at 0 y coordinate at initial. So let us consider that t is not 0 because I am not interested in this solution. I am interested in the non-zero solution. So I can safely divide by t. So what happens, it becomes minus 2g cosine phi. One t is gone, and this t is gone. So let me move this to the right-hand side. Okay, and don't forget, I am looking for t. This minus sign can be canceled with that minus sign. And what is t? T is 2 times V node sine theta minus phi divided by G cosine phi. Do you agree? Yes? So this is the time that takes for my particle to reach to this point. Yes? But I want to find the x coordinate at that time. So what I have to do, I have to plug this back into the x coordinate equation, and then I find the x value, which is d. Yes? So d so what is d? D is x calculated at this time. So let me take it here. Yes. This is my d. Is that equation understandable for everyone? Yes. Why this is this? So then what I have to do, I have to plug this into this equation. So what happens? It becomes minus a half, and then I have g sine phi. Instead of t, I put this expression, I raise it to power 2. It becomes 4 V node sine to the power of 2 theta minus phi, and then divided by g squared cosine phi squared. It becomes really horrible, I think, the calculation, but let us just don't give up and continue, okay? So I put this t in the x1. This is just the first part. And if I have done some mistakes, please let me know. I have raised it to power 2, and then I have this combination multiplied by t. So it becomes plus v node cosine theta minus phi multiplied by this t. So 2 v node sine theta minus phi, and then divided by g cosine phi. Yes? Understandable? Yeah, so it is not hard conceptually, but because numbers are not given to you, you need to work with algebra, trigonometry, and everything. In principle, we are done. This is the answer, yes? Is it an acceptable answer? I would say yes, because in physics, when I ask you to calculate this, you need to find the formula which expresses the quantity demanded in the problem in terms of what you know in the problem. So what you know, G is known to you, phi is known, theta is known, and V node is known. And everything is related to that. So it is a complete formula. But usually I told you that in hard problems, they ask you to simplify things as much as possible. So let us just do that. Now it's completely pure trigonometry. We want to trigonometric identity. I want to show that whatever V node, phi, theta are, this is always equal to that. So what is your suggestion? It's a little bit strange for me because because of that power of the sine to the power of 2. So do you think that I did something wrong? No, who cares? Let us. How do you start solving this problem? You need to always check what you want to get. Yes. What's your suggestion?
Common denominator.
Common denominator. Yes, it works, but instead of common denominator, let us do it a little bit easier. Instead of common denominator, let us factor things out. Okay, so what I do, I see that I need g cosine squared phi in the denominator. So what I think, I will take it out. I also need one of these signs. Do you agree with me? So, and I need, so the problem is that, okay, good. You see, there is a V node here, and there is a V node here, so it becomes V node to power 2. And here I have also a V node to power 2. So let us just do it in this way. So do you agree that it is a good idea to pull 2 V node out to the power of 2? Because I am looking here, I see that I need this as a factor. So don't try to, common denominator will work, but I'm just trying to give my own experience to you. So I will take this out, okay? And then don't worry, this 2 and that 4 actually gives me exactly the right factor. Yes. So 2V node, and I also have this one and this one 2V node. So that's good. Okay, but what I need more, I need cosine theta. Unfortunately, I don't see any cosine theta factor here to factor out. So that would be my problem. So let us keep it. But let us go to the next factor. Do you see a factor, the common factor of this in both of them? Yes. So let us pull it out, okay? So I would say that I will pull it out. Okay, so don't get confused. Now, so this means that I have taken care of this one. This is gone. I have taken care of this one. I have taken care of this one. I have taken care of this one. Remember, there is a negative sign left. Okay, and then there is a sign theta minus phi. I have pulled out. So this is gone. One of them is left. This is totally gone. Okay. And let us now go to the denominator. What do I need in the denominator? I need a factor of g. So I pull it out. It's good because this factor of g cancel one of them. One is left, and I pulled that out. Yes. And then here there was only one, and I have pulled it out. So that's also gone. Yes. And then let us go another factor. It's cosine squared phi. So let me take this. I want you to understand. I take cosine squared phi out. Okay. Now, can you tell me what is left in the pair of brackets? I want to test your how do you follow these things? Yeah. So what is left from the first one? Can you tell me? Minus
Sine phi times
yes.
sine theta minus phi over
No over.
Yeah.
That's it. So this is a better way to do it instead of doing common denominator. So that's it. Agree? So this is what is left when I pull everything out. That's completely true. That was my idea. So what is left? This is tricky a little bit. Can you tell me what is left from the second term? I want to write it first.
cosine phi times cosine theta minus phi.
Cosine phi, exactly. Yes? Why is that? Because I had only one factor of cosine in the denominator, but I pulled two factors out. So it means that to compensate for that, I have to multiply by an extra cosine of phi. Is that understandable? So I don't know. Do you agree that, Sanders, this is a little bit better than, of course, it is easy, it's not hard, but it's better than common factors, you know?
Yes.
So, especially when you know the formula. So you need to think it in this way. So more or less, we are very close now, yes? Because 2 we know the square appears here good. Everything in the denominator appears good. So then I have one problem. Cosine theta, instead of having cosine theta, I have this big expression. So how can I get rid of that big expression instead of cosine theta? If I have done everything right, this is not hard to guess. This should be equal to cosine theta. Otherwise, I have made something wrong. Yes? Why is that that's cosine theta? It's a matter of seconds. Why is that cosine theta? It needs two seconds to understand why that whole combination is just cosine theta.
Cosine adding 2.
Yes, that's the formula of the addition formula for cosine, yes? So, do you remember, if we have this formula, if you remember cosine, if I ask you cosine u plus v, this is why I'm saying that memory is important. If you don't have anything, you were completely blank, it is horrible why this is equal to cosine theta. If it seems familiar for you, you can guess something, you can immediately realize that this is this formula. Cosine of u plus v, of course, then you can go and check the formula sheet. If you are totally blank, it's not possible. So I have this scenario, yes? I have it in my memory, so that's the cosine of addition formula. But you see, let us give the role of u to this one. Let us give the role of v to this one. Yes? So this becomes cosine u, cosine v. This becomes sine u, sine v. So this expression is the right-hand side of this formula. So you can write the left-hand side for it. Yes? So it becomes what? It becomes cosine of u plus v. U is this, v is this. Yes? But immediately you see that they are gone, and this becomes cosine theta. So it's done. Yes? So you see that the mathematics is more involved here. Yeah, so this is why I'm saying that it is a very important thing. Coordinate systems, from physical point of view, it doesn't matter which coordinate system you choose to solve your problem. But from mathematical point of view, it's extremely important the choice of your coordinate system. One coordinate system might make your problem more involved mathematically. So you see that you need, I think this is more involved than the previous one if you go back here. So it is much involved here, but it is very, very important if you want to understand physics to be able to solve a problem in this form as well. Is that understandable? Okay. Now let me solve another problem. That is also, even that is, it's a little bit higher level. I got it from a book that is dedicated for physicists. They are studying this in the mechanics course, analytical mechanics. Okay, so let us try. You see that your mathematics knowledge is quite advanced, but you need to understand which type of problems. You need to appreciate what you know. This is the problem. I think Feynman is actually one of the Nobel laureates now, one of the geniuses. So he has a hobby. He was going to his colleague's office and saying that, okay, express a problem for them in a disguised form. He wanted to see how many of them understand that they know the problem. It's important, you know, you have a lot of math knowledge. You see, when I explain them, you understand them. But for example, if I start solving and explaining a triple integral for you, you might not be able to follow. So this means that that knowledge, that part is above your knowledge, but this is not above your knowledge. So in principle, if you have a project, I don't know, you should be able to do it by the mathematics that you have right now at this level. Okay, let me ask you this question and try to solve it together. It might be this is a little bit harder. So this is an athlete. An athlete stands at the peak of a hill. So let me just draw the picture. So that is a hill, for example. And you have your athlete standing here. That slopes forward, downward. So I don't need to explain these things because it is clear in the drawing, yes? So this angle is phi this time. But this angle, so that I don't know, this athlete is shooting or something. So this angle is theta, yes? So an athlete stands at the peak of a hill that slopes downward uniformly at angle phi, as in the following figure. So yeah, I mean, that's a bit exaggerating to make it real, but you can assume, you can model it with a straight line, yes? Show that the maximum range, or max, they call it in the problem, or max, the maximum range that the athlete can achieve on the hill is given by this formula. So we want to show that if this athlete shoots the particle, the ball or whatever, the maximum rate on this hill follows this formula. V node squared divided by G. So let me write it properly here. And by the way, if I ask you from your physical intuition, what this quantity should be related to something, what are the main factors? Just intuitively thinking. Yes. So G should play a role because this is related to the force. And of course, you probably understand that from physical intuition is that this phi should also play a role, yes? And this angle should also play a role. So in my formulation, and what else do you think, yes?
Initial velocity.
Initial velocity, because if I kick it, I don't know, stronger, it will go further. So this is immediately understandable. So this is the correct, but the details cannot come from physics only. You have to do math. You are thinking how crazy Bobak is?
No, I'm thinking if they are studying for test or...
No, they are studying just for fun. Yeah. Okay. So we want to prove this formula, but for example, if you are coach for this athlete, what is your main concern? Is it R max is your main concern? And what is your main concern, by the way? This just came to my mind right now. Of course, this is good because this tells you the limitation of the athlete, yes? So according to this, so if, by the way, there is no theta involved. It's very strange here. Okay, because R max doesn't depend on theta. R depends on theta. But if you want to maximize the range, you need to fine tune this angle. Do you understand? Because you might be the same person, but you are actually stupid. Instead of actually shooting it horizontally, you shoot it upwards, so that it goes up and comes back, the range is 0. Yes, you are the same person, but the range is 0. So the reason that theta is not involved in this problem, because we are talking about the maximum range. So it means that this athlete should actually fine-tune this theta in order to be able to achieve this maximum range. This maximum range probably, I think, I don't know what's your opinion, from practical point of view is good. For example, if you compare this maximum range of your, I don't know, your student with compared to a student from another country, if the maximum range that you calculate for your student is lower than maximum range of another student, your student will always lose to that guy. Yes, if he knows his job. You understand what I mean? Yes. So R max, even though it is good, it is giving you the limitation of your student that you are coaching the person. Yes. But it doesn't tell you how to achieve your maximum capacity. If you are a coach, probably you care more how to realize this number for my student. Yes. And so what does it mean? It means that I need to guide that guy how shoot your particle, because we know depends on your strength usually, so it doesn't change. Yes. But this angle is crucial. So you need to teach your student, if you want to shoot, try to shoot it in this angle, which will give you this maximum range. If you don't do it, you will not be able to reach your maximum capacity. So now this is the rest of the question. The rest of the question is this. Show also that when this maximum range is achieved. Okay, so that's the question. When this R max is achieved. Okay, so let us try to solve that problem. Yeah, we have a little bit of time. I think we can finalize this problem. So this is, by the way, do you agree that this is a real life problem? Yes. Of course, the only downside about it, if you want to be, for example, Miss King, I think I saw one of them. The first person compared to this person in rank 17, they just differ by 1 second. So this is not just probably every science goes there. So the first person, if you see this speeding skis, I think I remember, the first person compared to the first person in the 17th rank, they differ just by 1 second. So it means that you also need a lot of technology. The quality of this one, the air resistance that quality of cloth will actually make with the air drop. You need to consider air pressure if you want to achieve that 1 second. Okay, but forget about those things. But this is a real life problem. You want to actually coach your athlete to achieve the maximum value of the range. Okay, so how do you think we can solve this problem? First of all, this is typical. Which coordinate system you prefer to choose? You have to choose a coordinate system. Be careful. These are the fundamental steps that whenever you are dealing with a physical problem, you need to set up a coordinate system first, and then keep that coordinate system until the end of the problem. You cannot change it in the middle of the problem, you see? So, but now you have a little bit of experience. Do you prefer this inclined one or the normal one? So the normal one showed that mathematically is simpler. So let us set up this coordinate system. But let us play a little bit of game to this time. So this time, let me take the horizontal as before. But if you don't mind, I want to increase your skills. Let me take this coordinate system downward this time. Or is it a good idea? Because if I take it downward, I have to do everything from scratch again. Might be we don't have time. So let us keep it the other way around. Okay. Because I have some of those formulas in my memory, so let me just use them. Okay, so how do you solve this problem? Then whatever formula you need, I can write it down for you. So the first thing that I do, I set up a coordinate system. Yes. So how should I find? So this goes up and then goes below horizontal and then hits this hill. This is the range. This is the normal range of theta. But I want to find the maximum. I want to see which angle makes this range the maximum value. So how should I solve the problem?
Find the function for the motion of the ball or whatever it is.
Okay, that's the trajectory, yes? So let me write it for you here. I have it in my memory if I think. So if you have, this is the formula. Y is equal to minus G divided by 2V node squared, cosine squared of the theta. And then you have x squared, and then you have tangent of theta. If you have forgotten, you can refer to the previous video. We did it last time. So that is the formula for the trajectory. Yes? Okay. And then yes?
Couldn't you find the intersection point between that and
This line.
the line of the...
Yeah, so we can, this is just the reality. It's not completely smooth. But if you want to model something in physics, you don't need to bother first about these minor things. If you need more precision, of course, you need to care about these things. But in the first estimate, we really don't need to bother ourselves. We can assume that this is just a line. Okay, let me test your memory or whatever. What is the equation of this line now?
Then no minus tangent of phi.
Yes. So what is K? K is the tangent of the angle. The K value is the tangent of the angle that my line makes with the positive x direction. So you are right. This is this angle, which is 2 pi minus phi. Yes, so you are right. The K value is tangent of this bigger angle, which is 2 pi minus phi. And if you calculate this, it becomes what? It becomes, by the way, the period of tangent is pi. So I can just eliminate that. It becomes tangent of minus phi. Or of course, you can write it simply as tangent of phi. Minus tangent of phi. Tangent of minus phi is that one. So that's correct. So this is the K value. Yes? This is the K value of this line. One intersection point between this parabola, do you remember that's a parabola? So this equation, this is a parabola and this is a line. One intersection point is the origin. I will find this intersection point. Yes? But I don't want to do the algebra first. What is the goal? Assume that I did that. I find something for R. Then what? Do you expect that you see theta in that formula? Assume that, for the moment, assume that I did everything. I solved this system of equations, and then I found this point, and then I find this distance. Yes, it is possible, all of them in principle. But do you see that there is a theta dependence there? Yes? And then why theta is not here? Because we want to maximize that function. So it means that the notion of derivative comes in. Because I have a function, I want to maximize it. Is that understandable? So you see that all your mathematics you learn is actually useful in physics. This is a very nice, physics is a very nice setup stage to learn mathematics that you have learned so far. So what we do, we write this system of equations. tangent of phi x. We put them in a system and try to solve this system of equations. What are my unknowns? My unknowns are just x and y. Everything else is assumed to be known. Okay, now what I have to do you remember I told you that if you want to just naively solve this problem, it is horrible. Do you remember I used one trick to make the algebra simpler? Do you remember that? Because, so let me call r theta. What is r theta? Do you agree? R theta, this coordinate, let me call it x and y. X and y are these numbers. So r theta is the distance of this point to the origin, which is the square root of x squared plus y squared. But y has this relation with x, so I can write it as x squared. Instead of y squared, I can write tangent squared phi times x squared. And then, do you remember, I factor x squared out. So this becomes 1 plus tangent squared phi x squared. Yes? And then I told you this is a famous combination in trigonometry. Do you remember or not? So what is this combination? 1 plus tangent squared. Do you remember something about
over cosine squared?
Exactly. Thank you. So you have changed to think about you really need to remember the formulas. So they are really useful. Okay, and then it becomes absolute value of x cosine phi. But do I need absolute value here? Always I need absolute values. But then in this setup, x is positive, you see, and phi is an angle between 0 and pi over 2. So cosine phi is also positive, so I can safely remove the absolute value because whatever is inside is positive. Yes? So this is the distance d. But it is not done yet because unfortunately I don't know x yet. So I have to calculate and find x. So how can I find that? I equate the y's together. So I equate the y's, and then I find my x. And then I plug it back here. So let us just do that. If I now equate the y's, what happens? It becomes minus g over 2v node squared cosine squared theta x squared plus tangent of theta times x is equal to minus tangent phi times x. Can I divide by x everything, both sides, because I'm looking for x, but I know that I am looking for this x, and it is clear that x is not 0 here. So I am on the safe side, so I can divide. It's crucial, by the way, be careful. Because x is not equal to 0, I can divide everything by x, so this becomes minus 2. Let me just write it down quickly. Do you agree? Oh, sorry. I dropped x. And then what is the next step? I move it to the right. It becomes minus minus. I will also have a minus. I get rid of all minus signs. X is equal to tangent theta plus tangent phi. And I am looking for x. So x becomes 2v node squared cosine squared theta divided by g multiplied by tangent theta plus tangent phi, yes? So that is my x. I'm not explaining that much because they're simple algebra, yes? You just convince yourself it's not hard. But I want you to understand the logic. Don't get lost in the heavy calculations. Nothing is actually very hard. So what I have to do, I have to calculate r theta now. I have to put x, this is my x. I divide my x by cosine phi and I am done. So r theta is that expression divided by cosine phi. So are you following or not? It's not hard, yes? I'm just doing some algebra. Okay, but this, how should I come to this point? That is another story. Yes? So what is your suggestion? This is what if I ask you what I have calculated, can you tell me what is this calculation? This calculation gives me the range if the angle is theta. Because V naught is fixed, phi is the line, is this angle, which is fixed because I'm not changing the hill. So I have one variable, and that is theta. So if I change theta, this will change. And this is reasonable, yes? So I got a function. So by the way, instead of writing like this, let me write it as a function. R is a function of theta. So now what do you want to do? You want to find the maximum value, and you also want to see when that maximum is achieved. Is that understandable? But this is just a simple math 4 problem. It would be harder here because you need to work a little bit more heavy calculations, yes? But except for that, everything is. So what is your suggestion now? Yes? First derivative test or second derivative test. The first thing is that I have to differentiate. Don't get confused. What is my variable of differentiation?
Theta.
Theta, yes? Don't get confused. You have written a lot of variables here. They are not variables, they are parameters, but theta is my only variable. Now you are doing some mathematics. So you have to use all your experience that you have in mathematics to simplify the calculations, if possible. But most of the time, practical problems are not user-friendly, so you need to suffer a lot. Okay, so if you want to maximize this function, you want to differentiate. What is my problem here in differentiation? Do you have any idea?
It's multiply.
Yes. I want to, yeah, we have to multiply. Let us multiply, yes? Because this one is a constant. Don't bother yourself for this one. That's just a constant. 2 V naught G cosine phi is a constant. So I multiply this inside. So this becomes, let me just write it. 2 V naught squared divided by G cosine phi. So let us do it in our head. If I multiply this here, how can I simplify? Tangent is sine over cosine. One of these cosines with the cosine in the denominator will be cancelled. So from this one, a sine will be left and a cosine will be left. I will multiply them. So it becomes sine theta, cosine theta. Agree? And then I multiply cosine squared in that one. And if you don't mind, let me multiply 2 inside. Let me multiply 2 inside. Why do you think I am doing that? Because this combination is familiar for me, yes? I multiply 2 inside as well. Yes? But this combination is what? Yes, exactly. If I don't do that, I have to use the product rule to differentiate. But when I do that, it is simple to differentiate. So you need to be a little bit skilled in these calculations. So it becomes V naught squared G cosine phi. And then I start differentiation. So sorry, let me just differentiate right now. I want to differentiate it. It becomes what? This is a constant. And then the derivative of sine, this is the chain rule. So it becomes cosine 2 theta multiplied by the derivative of 2 theta, which is 2. And this is the chain rule as well. So 2 goes down. So it becomes 4 cosine theta, but multiplied by the derivative of the cosine theta, which is minus sine theta. So it becomes minus 2 cosine theta sine theta. Do I need to bother about this part? Not at all, because phi is a constant. And tangent phi is also a constant. So you see, you are actually repeating what you have learned in a very nice setup. Yes? Yes? Is that understandable? And the nice thing here is that again this combination appears. So that is again sine 2 theta. So let me just finalize everything. So r prime of theta is v naught squared divided by g cosine phi. And then what do I have here? I have 2 cosine 2 phi. 2 cosine 2 theta minus sine 2 theta. And then I have tangent of phi. That is a little bit strange for me because there is an extra factor of 2 that I don't like it there. Did I make mistake for a 2 there or something? So I move 2 inside with me. Do you see any flaw in there? Oh no. I don't see any flaws, but the problem is that this 2 is problematic. I can see the future a little bit here. Let me double check if I have done everything. I made a mistake, yes. Because 2 goes there, it becomes 4, yes? It is 2. So there is a 2 left here. Yes? Yes? Is that right? So that is a 2. I actually saw what's happening. So 4 cosine, because 2 goes down, it becomes 2 times 2, 4 cosine theta multiplied by the derivative of cosine theta, which is minus sine theta. So this minus sign is coming from the derivative of cosine. This 4 is coming from this 2 by 2. But 2 times sine cosine is sine theta, so there is a 2 left. Yes. So yeah, if you want this combination is this. Okay, so now everything works fine. Yes, because I saw that this is a real problem here for us. Okay, then what happens? So I put it equal to 0. So r prime theta is equal to 0. This cannot be equal to 0, so it means this should be equal to 0. So then this means that 2 cosine 2 theta is equal to 2 sine 2 theta tangent phi. Yes? And then let me keep that one. I will clean this. So what is your way of how do you solve this? By the way, it's a trigonometric equation. You are looking for theta. So what do you think I can do for solving this equation? It's clear that I can simplify this 2 with that 2. Then what happens? It's a nice problem. Can you see that, by the way? This can be a level 3 problem in Math 4.
Divide both sides by cosine 2 theta.
Yes, that's a good idea, but then can you see why? So let us follow you, okay? Let us follow you. So you say that divide both sides by that, yes? What happens? It becomes 1. This becomes tangent again, because sine divided by the cosine, it becomes tangent. And tangent phi. Yes, that's correct. But still, something is missing. So what should I do now? How can I solve this? I'm looking for tangent of 2 theta.
Divide by tangent phi.
That is the reason that I am avoiding that. If I wanted to solve that, I definitely will do that. The reason is that you are not very familiar with cotangent. Yes, if I want to solve this problem myself, I definitely divide by tangent. 1 over tangent is called cotangent. And if a cotangent is equal to tangent, I know that the sum of the angles is phi over 2. It's exactly like sine and cosine. If sine of an angle is equal to the cosine, then it means that the angles should sum to 90. But let us avoid that, okay? That is the simplest way, definitely. But if I want to solve it at the level that you have seen that, I would write it as in terms of sine and theta. In principle, I don't divide and write it in this form. I would write it in this form. Do you agree? Instead of tangent, I write sine over cosine. Instead of tangent, I write sine over cosine. But what I do, this means that cosine 2 theta, cosine phi, minus sine 2 theta, sine 2 theta, sine phi is equal to 0, yes? This is the meaning. If these two, if this divided by that is 1, it means the numerator and the denominator are equal. So it means the difference between the numerator and the denominator is 0. But why this is useful? This is just the formula we learned, we repeated again today. This is what? This is the cosine of 2 theta plus phi. Yes? And this is equal to 0. That is the cosine of 2 theta plus phi. And then this is easy to solve, yes? Because cosine of 2 theta plus phi is 0, so it means 2 theta plus phi is actually pi over 2. Yes? And I don't need to consider other angles, because here it is in physics. We don't need to find all angles, negative angles. I don't care about angles greater than 360 degrees. So that is the only solution which is possible in this context. But I am looking for theta. Yes, so what is theta then? It is this number minus phi multiplied by 1 over 2. So this is my theta. So let us go back, let us wait a little bit. Do you understand what is going on? If someone asks you what you have been calculating so far, what is that? Yes?
The angle to throw at to get the max distance.
Yes. So if you are the coach of this person, you need to ask him to try to train himself so that he can shoot the ball with this angle, 45 degrees minus this angle divided by 2, gives you the maximum range, which was not trivial at all if you just want to coach someone by intuition. Yes, it's really, I don't know, do you intuitively can guess this? Pardon? Pardon?
If you want to be a coach, you also have to measure
Yes, of course. I think there are simple instruments, because I know that people can measure the velocity, how fast these people can actually shoot the particle. So this you know, but you need to train. You need to tell the person, and this is a characteristic of the field that you are doing the matching. So probably this angle is provided for you by the, I don't know, by the people that you are that they are set up in this thing. So you know phi. You know the ability of your student. So, and then, but this is a really nice advice. So that person should try to learn how to shoot with this angle. Yes? Then this person can reach the maximum level. But at the mathematical level, it is not done yet, because this might be a terrace point or a maximum point or a minimum point. Yes? Because I just calculated the derivative and put it equal to 0 and got an answer. Yes, so you need to convince that this theta is actually corresponds to a maximum. How should we do that? How should we do that? For example, we can calculate the second derivative and put this one in there, and then convince ourselves that the number is positive. If the number is negative. If the number is negative, it corresponds to this one. But still, this part of the problem is not solved yet, because we are supposed to find our maximum. So that was a hard problem. I told you this is more advanced than the level. This is probably year 2 or 3 in physics major. Okay. So how should we calculate that one? We have a little bit of time. So assume that you convince yourself that is indeed a maximum one. Of course, in this problem, it is not clear. It is clear that we don't have a minimum. So if you want to have a minimum, you can shoot upwards. Yes. That is 0. So that's ridiculous. So probably that's good idea in this physics context. But how can I reach that formula given in the problem? I want to calculate R maximum in this case. So what I have to do? Yes?
We calculate our theta at that value.
At that value. That's the meaning. Yes. If I put that back in where was the form? Do I have it or not? Oh, I erased that. Unfortunately. So what was that? Yeah, I think this was the formula. Here I started differentiation. So that was the formula. So let us just do the last step. So I put this angle into here. Let us see how it works. So if I put that there, then this becomes V node squared divided by G cosine phi. Okay, so let us just do it in our head. I need 2 theta. I multiply it by 2, it becomes pi over 2 minus phi. But I want to calculate sine. But sine of pi over 2 minus phi is nothing except cosine phi. Agreed? And then I go here. Okay, so that's a little bit problematic. So you need to immediately recognize another formula. So 2 cosine squared theta is 1 minus cosine 2 theta. This is the double angle formula. So if I put this angle here, instead of putting it here, I put it here. Again, the same story. I multiply it by 2, it becomes pi over 2 minus phi. Cosine becomes sine. So it becomes 1 minus sine. Plus 1 minus sine phi. And then you have tangent of phi. Yes? So this is a formula. This is the double angle formula for cosine. That first part you see here, using this formula can be written in this form. Then I multiply theta by 2. Cosine of this becomes cosine of phi. And I wrote it there. Yes? So then we have to simplify quite a lot, actually. So do you want to use the same trick here? So I would write V node squared G cosine phi. What I have to do, I have a cosine phi in this denominator. I pull it out, so it becomes cosine squared because I need it. Yes. So can you tell me what is left? This doesn't have any extra cosine, so I would write it as cosine phi squared. Yes. And then this becomes plus 1 minus sine phi, and then you have sine phi. No, there is something wrong. There is a minus sign error. Sorry. The minus sign error is coming from here. This is positive. I made a mistake there. So this becomes positive. And this becomes positive, and we are done. Why? Because I multiply this here. It becomes sine squared plus cosine squared, which is 1. And then this is sine. And then we are done. This is exactly this expression. And this is exactly that expression. So this formula was not right. This is positive. Okay. But even though this is a really seems hard problem, but the math was exactly at the right level of your math, yes? So don't underestimate yourself. You know a lot of mathematics. So if you can use them properly, you can solve really, really hard problems. Any questions? No? Okay, so we can end. This is the last session of math specialization. That was good. We also talked 2 sessions with a little bit of mechanics here. But I think I don't want to distract you with details, but I think you learned a lot of things. You see, you see that in practice, every detail that we were talking were more or less related here. So you see, it's really involved with a lot of trigonometry, derivatives, integrations, and everything. If you want to solve such a it's in practical life, it's actually a very, very simple problem. Yes, assume that you want to send a shuttle to Mars, you need to calculate the trajectory for 7 years. You know, and then by the way, it's very interesting. If you see, I was listening to it. I was watching a documentary, so it's very nice. You know that there were 2 rovers that NASA sent actually to Mars, and they landed in 2011 or something, but they didn't have a powerful rocket to send it directly to Mars. So what they did, actually, this is, I don't know, this is, for example, Earth, this is Sun, I think Venus is here. I don't remember the order, but Mars is a little bit far away. So they didn't have enough powerful rocket to shoot it directly to Mars, but what they did, actually, they shoot it to Venus, because what happens if you because it's possible to calculate, if you send it very close, the gravity of this will pull it and it will crash. Okay, if you send it with different bad velocity, bad angle, this will actually deviate the trajectory, but this will escape. But there is a very fine-tuned trajectory. If you send it like that, then this Venus will act as a slingshot. So it will actually rotate this, and when it is going back, the velocity is much higher from here. So they calculated this trajectory. I don't know, they send it to Venus and then calculated that the angle should be somehow that after 2 or 3 years, it returns to Earth, and the Earth do the same slingshot again for this rocket and then send it to Mars. Then it will reach to Mars in 7 years. So you can see that this is really astonishing how mathematics is so powerful that if you just do something on paper, of course they did it in computer, but more or less that's mathematics there. So this is extremely complicated. It seems to me extremely complicated calculation, you know. So you just send it, after 4 years, your rocket is still on Earth, but then at the last time, it will be shooted actually to Mars. And this so it took 7 years for this happening, yes? But everything goes smoothly as they predicted. Okay, so now compare that problem with that problem, so you can compare the level of math involved in that problem, because here you cannot use Newtonian mechanics, you have to use Einsteinian mechanics, yes? So relativity should be involved, yes? And by the way, if you just calculate everything in GPS using Newtonian mechanics, GPS will fail. So you have to involve the higher, the more precise theory that we have about gravity, and that is general relativity. If you don't calculate things according to general relativity, which is actually probably a little bit astonishing, GPS is not accurate. Probably you will reach the point that you want to reach with 2 or 10 kilometers a mistake or something like that. So if you don't consider that, so it means that if we just knew Newton's gravity, we didn't have GPS. So yeah. Anyway, thank you very much. So that was the last session of mathematics specialization formally. Thank you very much. Bye-bye.